Let's derive quadratic formula. Our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Now we're going to derive this formula. Let's use completing the square technique. Our standard form for quadratic functions is ax squared plus bx plus c equals to 0. We're going to complete the square, so we need constant on the right hand side. So let's subtract c on both sides. So we obtain ax squared plus bx equals to negative c. Now we need to divide everything by a because we need the coefficient of x squared 1. Now we obtain x squared plus bx over a equals to negative c over a. Now we are ready to complete the square. We need to take the half of the middle term and square it and add it on right and left hand side. So half of b over a is b over a times 1/2, which is b over 2a. Now we need to square this, and if we square it we obtain b squared over 4ac, and we add it on left and right hand side. Now we obtain perfect square trinomial on left hand side, so we can easily factor this out. Take the square root of the first term, the sign in between is plus, and take the square root of the third term, and don't forget to square the quantity. On the right hand side we have two fractions that we can merge. B squared over 4a squared minus c over a. We can expand c over a with 4a over 4a, so we obtain the common denominator, and we can merge it. So on the right we have b squared minus 4ac over 4a squared. Now we can take the square root on both sides, and when you take the square root don't forget plus or minus sign. On the left hand side we have x plus b over 2a, and on the right hand side we have square root of b squared minus 4ac, and we can take 4a squared outside of the square root sign. Now we can subtract b over 2a on both sides, and if you change the order, use this fraction first and that fraction second, you obtain the quadratic formula. And a cannot be equal to 0, or else the function will be undefined, or your standard form won't be a quadratic function. B and c are real numbers. Thank you for watching.